Imagine holding a battery no bigger than your hand. It feels cold, silent, and almost lifeless. But hidden inside that tiny metal shell is enough stored energy to start a car, power a smartphone for days, or even move a vehicle weighing 2 tons. Most people never think about this, but every battery begins its life buried deep beneath the Earth's surface, thousands of kilometers away from the factory where it is finally assembled. Think about this. Before your phone ever lights up or your electric car quietly pulls away from a traffic light, hundreds of engineers, miners, chemists, and robots have already spent months working together across multiple continents. You see a battery. We see one of the most complicated manufacturing achievements humanity has ever created. And this is where it gets truly extraordinary. But here's what nobody tells you. Nearly every battery is actually the final chapter of an incredible global journey. The metals inside it may have traveled over 50,000 kilometers before meeting each other inside a single factory. Every gram has a story, and every ingredient has survived crushing pressure, scorching heat, and some of the harshest environments on Earth. By the end of this journey, you'll never look at a battery the same way again. Everything begins with lithium, one of the lightest metals on Earth. Around half of the world's lithium comes from Australia through hard rock spodumene mining, while enormous salt flats in Chile and Argentina supply much of the remaining production. Workers blast solid rock or pump mineral-rich brine from beneath ancient deserts before refining it into battery-grade lithium carbonate with purity levels exceeding 99.5%. Lithium may get all the attention, but cobalt tells a far more complicated story. Nearly 70% of the world's cobalt supply comes from the Democratic Republic of Congo, where miners extract cobalt-rich ores before shipping them to refineries around the globe. Modern battery manufacturers increasingly rely on certified supply chains to improve traceability and responsible sourcing, because the journey of every kilogram matters as much as the chemistry inside the finished cell. Now imagine enormous mountains of black graphite. Most people assume it's just another ordinary mineral, yet it becomes one of the most important parts of every rechargeable battery. China dominates natural and synthetic graphite production, while advanced purification removes microscopic impurities until material reaches battery-grade quality, exceeding 99.9% carbon. Without this remarkable material, modern lithium-ion batteries simply wouldn't work. Nickel, manganese, copper, and aluminum complete the recipe. Nickel often arrives from Indonesia and Canada. Copper may travel from Chile or Peru, while aluminum begins as bauxite mined in Australia, Guinea, or Brazil before transforming into lightweight foil. By the time these materials reach the battery factory, they've crossed oceans aboard cargo ships, trains, and trucks carrying thousands of tons every single day. Every shipment undergoes laboratory testing before entering production. Engineers analyze particle size, moisture content, chemical composition, and contamination levels measured in just a few parts per million. A single impurity invisible to human eye could shorten battery life by years, or even create dangerous internal failures. What happens next surprised even experienced engineers, because this is where chemistry transforms into one of the cleanest manufacturing processes on Earth. Before production begins, every factory must control something you can't even see: humidity. Battery manufacturing demands some of the driest rooms on Earth, often maintaining dew points below minus 40 degrees Celsius. Imagine air so dry that even a tiny drop of moisture could ruin thousands of battery cells worth millions of dollars. And now, we're finally ready to step inside the heart of the factory, where raw minerals become stored electricity. The moment finally arrives. Inside one of the cleanest factories on Earth, giant automated mixers combine lithium compounds, graphite, conductive carbon, and advanced polymer binders into a thick black slurry. Powerful vacuum mixers spin between 300 and 800 revolutions per minute for nearly 2 to 4 hours, removing every microscopic air bubble, because even one trapped bubble could shorten the battery's life. The room feels almost silent except for the deep hum of precision motors, and the smell of industrial solvents hangs faintly in the filtered air. What happens next surprised even experienced engineers, because this liquid will soon become the heart of every battery. Now the slurry moves into one of the most precise coating machines in the factory. Thin copper foil for the anode and aluminum foil for the cathode race through coating rollers at speeds of 20 to 80 meters per minute. Laser-guided coating heads spread an incredibly uniform layer only a few hundred microns thick. If the thickness varies by even 5 microns, the entire roll may be rejected because uneven coatings create uneven charging. Freshly coated electrodes enter drying ovens, stretching dozens of meters across the factory floor. Heated air between 80 degrees Celsius and 150 degrees Celsius, 176 to 302 degrees Fahrenheit, evaporates every trace of solvent during a journey lasting 10 to 30 minutes. Warm air rushes through the tunnels, while sophisticated recovery systems capture valuable chemicals for reuse. Think about this. Nothing gets wasted if engineers can help it. Next comes calendaring, where enormous polished steel rollers squeeze the electrodes under pressures exceeding 80 to 120 tons. The rollers compress material until every particle packs tightly together, improving energy density and electrical conductivity. You hear a steady metallic rumble as thousands of meters of electrode material glide smoothly through the machine. The transformation looks simple, but it dramatically changes how much energy the battery can store. Powerful laser cutters now slice the electrodes with astonishing precision. Computer-controlled systems maintain dimensional tolerances within plus or minus 0.05 millimeters, ensuring every sheet matches perfectly. Tiny scraps fall away into recycling bins while finished electrodes stack automatically for the next stage. Every movement happens faster than the human eye can comfortably follow. And this is where it gets truly extraordinary. High-speed robots begin stacking or winding the electrodes together with an ultra-thin separator film that prevents short circuits while allowing lithium ions to flow freely. Cylindrical batteries roll into perfect jelly roll shapes, while prismatic and pouch cells build perfectly aligned stacks. Some assembly machines produce more than 60 cells every minute, working with breathtaking precision around the clock. The unfinished cells now enter an ultra-dry chamber where electrolyte is injected under carefully controlled vacuum conditions. The electrolyte contains lithium salts dissolved inside highly purified organic solvents, creating the pathway that allows ions to travel between electrodes. Engineers carefully control pressure close to 1 bar vacuum to eliminate trapped air pockets. Even the smallest bubble could reduce performance or create dangerous hot spots during charging. Once filled, every battery is permanently sealed using high-energy laser welding systems. Brilliant flashes of light appear for only milliseconds as lasers fuse microscopic metal seams together. Sensors inspect every weld immediately after completion, searching for defects measured in mere microns. The factory may look calm, but millions of microscopic quality decisions happen every single second. Now comes the slowest and perhaps most important stage of the entire journey. Newly sealed batteries connect to massive charging racks for the formation process, where they charge and discharge under carefully controlled conditions for 24 to 72 hours. During this time, a microscopic protective layer called the solid electrolyte interface forms naturally inside every cell. Most people never think about this invisible layer, yet it determines whether your battery lasts 2 years or 10. Before a single battery reaches a customer, every cell must prove itself. Advanced inspection systems measure voltage, internal resistance capacity, temperature behavior, and microscopic leakage. AI-powered cameras inspect the exterior, while X-ray scanners peer inside without opening the battery. But one final challenge still remains, and this last test decides whether the battery earns its place inside your phone, laptop, or electric vehicle. Now the real pressure begins. Every finished battery enters an advanced quality control laboratory where engineers deliberately push it to its limits. Some cells are charged and discharged thousands of times, while others face crushing forces, violent vibrations, and extreme temperatures ranging from minus 40 degrees Celsius minus 40 degrees Fahrenheit to 85 degrees Celsius 185 degrees Fahrenheit. What happens next surprised even experienced engineers because the goal isn't to prove the battery works. It's to discover exactly how it could fail. Artificial intelligence now watches every battery more carefully than any human ever could. High-speed AI vision cameras inspect thousands of cells every hour, identifying scratches, dents, microscopic cracks, and tiny alignment errors smaller than 20 microns. Laser scanners build a complete 3D map of every battery, while intelligent software predicts defects before they become failures. The rejection rate at premium factories stays below 2%, proving that precision matters more than speed. And this is where human experience still beats machines. When automated systems detect an unusual defect, skilled technicians examine the battery under powerful microscopes before making the final decision. Years of experience allow them to recognize subtle imperfections that algorithms sometimes misinterpret. Even inside the world's smartest factories, human judgment remains the final layer of quality assurance. Think about this. The world now produces well over 1 terawatt-hour of lithium-ion battery capacity every year, enough to power millions of electric vehicles and billions of portable electronic devices. The global battery market has already grown beyond $150 billion and continues expanding at remarkable speed. Every day, enormous factories add new production lines just to keep up with worldwide demand. China leads global battery manufacturing with well over half of worldwide production capacity, followed by South Korea, Japan, the United States, and rapidly expanding facilities across Europe. Together, these nations employ hundreds of thousands of highly skilled workers, while millions more contribute through mining, refining, transportation, engineering, and recycling. Every battery represents one of the most connected industrial supply chains on Earth. Did you know that a modern electric vehicle battery pack may contain thousands of individual cells working together as one giant energy system? Did you know some battery factories now operate almost 24 hours a day using thousands of synchronized robots? And perhaps the most astonishing fact of all, future solid-state batteries could store significantly more energy while charging faster and improving safety, transforming transportation once again. Over the last 50 years, batteries have evolved from simple portable power sources into one of the most important technologies driving modern civilization. They now power satellites orbiting Earth, life-saving medical devices, smartphones, renewable energy storage systems, and the next generation of electric transportation. The next decade promises even lighter, safer, faster charging batteries with greater energy density than ever before. We've traveled from remote lithium mines and massive graphite refineries to one of the cleanest and most advanced manufacturing environments ever built. You've seen how chemistry, robotics, artificial intelligence, and human expertise combine to create something that quietly powers the modern world. Every battery carries the story of thousands of people, countless machines, and extraordinary engineering hidden beneath its simple metal shell. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.